Okay, welcome back to our lessons on A+, how to manage and maintain your PC. This is Chapter 6, Part 2, and we'll be discussing how to install and select hard drives. Now in this part of the chapter, you're going to learn how to select a hard drive for your system, and to learn the details of installing a SATA drive and an IDE drive in a system. Next, you'll learn how to deal with using removable bays and the problem of installing a hard drive in a bay that is too wide for it. You'll also learn how to set up a RAID system. Now, selecting a hard drive. When you're selecting a hard drive, keep in mind that to get the best performance from the system BIOS and the hard drive must support the same standard. And if they don't support the same standard, they revert to the slower standard that both can use, or the drive will not work at all. Now, there's no point in buying an expensive hard drive with features that your system cannot support. So therefore, when making purchasing decisions, you need to know what standards the motherboard or controller card providing a drive interface can use. Now, to find out the documentation for the board or the card, now for the motherboard, you can look at a BIOS setup screen to see which standards are mentioned. However, know that when installing a drive, you don't need to know which ATA standard a hard drive supports, because the startup BIOS uses auto detection. Now with auto detection, the BIOS detects the new drive and then automatically selects the correct drive capacity and the configuration for it, including the best possible standard supported by both the hard drive and the BIOS and the motherboard. So when you are purchasing a hard drive, consider the following factors that will affect your performance: use and price, the capacity of the drive. Now today's hard drives for desktop systems are in the range of 60 gig for SSD to more than 2 terabytes for your magnetic drives. Now the more gigabytes or terabytes, the higher the price. Magnetic drives have large capacity for the money than the solid-state drives. The spindle speed magnetic hard drives for desktop systems run at either 5400, 7200, 10,000 or 15,000 RPMs, which I mentioned in the last lesson. Now the most common is 7200 RPMs. The higher the RPMs, the faster the drive. And then also the faster the read-write access. Now the interface standard uses the standards that your motherboard supports. So for SATA, most likely that will be SATA 2 or 3. And for PATA or IDE, most likely that will be the Ultra ATA 100 or 133. Now for external drives, common standards are eSATA, FireWire 800 or 400, and the Super Speed or High Speed USB. The cache or the buffer size for magnetic hard drives, buffer memory improves the hard drive performance and can range from 2 meg to 64 meg, and the more the better. So the cost goes up as the size increases. The buffer helps because the hard drive reads ahead of the requested data and then stores the extra data in the buffer. This way, if the next read is already in the buffer, the controller does not need to return to the spinning platters for the data. Now, buffering especially improves performance when managing large files, such as when working with videos or movies. Now, a hard drive manufacturer might produce both magnetic drives and solid-state drives. Now, some hard drive manufacturers, which are listed in the table here behind me, most manufacturers of memory also make solid-state drives. Now, let's turn our attention to the step-by-step process of installing, say, a serial ATA drive. A motherboard that has SATA connectors might have an IDE header too. So an IDE header can be used, say, for your optical drive or some other eIDE drive, including a hard drive. But SATA drives are faster than PATA drives, so it's best to use the IDE header for other types of drives other than the hard drive. Now, as you can see here, you can see the back of 2 hard drives, and one uses a SATA interface and the other uses a PATA interface. Now notice that the PATA drive has a bank of jumpers. Now these jumpers are used to determine whether or not it's going to be a master or slave settings on the IDE channel. Because the serial data cable accommodates only a single drive, there is no need for jumpers in the drive for a master or slave settings. However, a SATA drive might have jumpers used to set features such as the ability to power up from standby mode. Now, most likely, if jumpers are present on a SATA drive, the factory has them set as they should be and advises you not to change them. Some SATA drives have two power connectors, as does the one in the figure behind me. Now, choose between the SATA power connector, which is the preferred connector, or the legacy 5-pin Molex connector. But never install two power cords to the drive at the same time, because this could end up damaging your drive. Now, if you have a PATA drive and a SATA connector on a motherboard, or you have a SATA drive and a PATA connector on a motherboard, you can purchase an adapter to make the hard drive connector fit your motherboard connector. Now, as the figure behind me shows, we have two converters. One converts SATA to PATA motherboards, and the other converts PATA drives to SATA motherboards. Now, when you use a converter, note that the drive will run at a slower PATA speed. You can also purchase a SATA and or PATA controller card that can provide internal PATA or SATA connectors and external eSATA connectors. You might want to use a controller card when, say, 1, the motherboard drive connectors are not functioning, or 2, the motherboard does not support an ATA standard and you want to implement such as a SATA 3 drive. Now, as the figure behind me shows, it shows a storage controller card that offers one Ultra ATA 133 IDE connection and then 2 internal SATA 1 connections and 1 eSATA port. And now let's look at the step-by-step process of installing a SATA drive. Step 1. Know your starting point. As with installing any other devices, before you begin installing your hard drive, make sure you know where your starting point is. Do this by answering these simple questions. How is your system configured? Is everything working properly? Verify which of your system's devices are working before installing a new one later. And if a device does not work, the information will help you isolate the problem. Keeping notes is a good idea whenever you install new hardware or software or make any other changes to your computer system. Write down what you know about the system that might be important later. Step 2. Read the documentation and prepare your work area. Before you take anything apart, carefully read all the documentation for the drive and controller card, as well as the part of your motherboard documentation that covers hard drive installation. Make sure that you can visualize all the steps in the installation. If you have any questions, keep researching until you locate that answer. You can also call technical support or ask a knowledgeable friend for help. But as you get your questions answered, you might discover that what you're installing will not work on your computer, but that is better than coping with hours of frustration in a disabled computer. You cannot always anticipate every problem, but at least you can know that you made your best effort to understand everything in advance. What you learn with thorough preparation pays off every time. You're now ready to set out your tools, documentation, new hardware, and a notebook. Remember the basic rules concerning static electricity, which you learned in the earlier chapters. Be sure to protect against ESD by wearing a grounding bracelet during that installation. You need to also avoid working on carpet in the winter and when there's a lot of static electricity. Some added precautions for working with a hard drive are as follows. Handle the drive carefully. Do not touch any exposed circuitry or chips. Prevent other people from touching exposed microchips in the drive. And when you first take the drive out of the static protective bag, touch the package containing the drive to a screw holding an expansion card or a cover, or to a metal part of the computer case for at least 2 seconds. This will drain any static electricity from the package and from your body. And if you must set down the drive outside the static protective package, place it component side up on a flat surface. Do not place a drive on the computer case cover or a metal table. And if you're assembling a new system, it's best to install drives before you install the motherboard so that you will not accidentally bump sensitive motherboard components with the drives. Step 3. Install the drives. So now you're ready to get started. Follow these steps to install the drive in the case. Number 1, shut down the computer, unplug it, press that power button for 2 seconds to drain any residual power that's being held in the capacitors. Remove the computer case cover and check that you have an available power cord from the power supply for the drive. Decide which bay will hold the drive. To do that, examine the locations of the drive bays and the length of the data cables and the power cords. Bays designed for hard drives do not have access to the outside of the case, unlike bays for optical drives and other drives in which disks are inserted. Also, some bays are wider than others to accommodate wide drives such as a DVD drive. Now, will the data cable reach the drives and the motherboard connector? If not, rearrange your plan for locating drive in the bay, or purchase a custom length data cable. Some bays are stationary, meaning the drive is installed inside the bay because it stays in the case. Other bays are removable. You remove the bay and install the drive in the bay, and then you return the bay back to the case. Step 3. For a stationary bay, slide the drive in the bay and secure one side of the drive with 1 or 2 short screws, as you can see here behind me. Now, it's best to use 2 screws so the drive will not move inside that bay. But sometimes the bay only provides a place for a single screw on each side. Some drive bays provide 1 or 2 tabs that let you pull out before you slide the drive in the bay and outside the bay, and then push the tabs into a secure drive. Another option is a sliding tab, like you can see behind me, that is used to secure the drive. You pull the tab back, slide in the drive, and then push the tab forward to secure the drive. 4. When using screws to secure the drive, carefully, without disturbing the drive, turn the case over, put on 1 or 2 screws on the other side of the drive, as you can see behind me, and then to best secure the drive in the case. Now, use 2 screws on each side of the drive. 5. Check the motherboard documentation to find out which SATA connectors on the board to use first. For example, 5 SATA connectors are shown in the board behind me. Now, the documentation says the 2 blue SATA connectors support 6 gigabits and slower speeds, and the 2 black and red SATA connectors support 3 gigabits per second and slower speeds. Now, on this board, be sure to connect your fastest hard drive to a blue connector. For both the drive and the motherboard, you can only unplug the cable you can only plug the cable into the connector in one direction. Now, a SATA cable might provide a clip on the connector to secure it, as you can see here behind me. Step 6, connect a 15-pin SATA power connector or a 5-pin MOS connector from the power supply to the drive. Check all your connections, power up the system. Next, verify the drive was recognized correctly. Enter the BIOS setup and look for the drive. It shows, that's figure behind me, it shows a BIOS setup screen on one system that has 2 SATA connectors and 1 PATA. Hard drives installed on the SATA connector and a CD drive is installed on the PATA connector. You're now ready to prepare the hard drive for the first use. Now, if you're installing a new hard drive in a system that is to be used with a Windows installation, boot from the Windows Setup DVD and follow the directions on the screen to install Windows on the new hard drive. If you're installing a second hard drive in the system that already has Windows installed on the first hard drive, you can use the disk management utility in Windows to prepare the drive for first use in doing something called partitioning and formatting that drive. Now, how to install Windows will be covered later on, and how to use disk management is covered in Chapter 10. Now, let's look at installing a hard drive in a removable bay. Now, let's see how the hard drive installation goes when you're dealing with this removable bay. Now, as the figure shows behind me, it shows a computer case with a removable bay that has a fan at the front of the bay to help keep the drives cool. The case manufacturer calls the bay a fan cage. Now, the bay is anchored to the case with 3 black locking pins. A third locking pin from the bottom of the case is disconnected. Unplug the cage fan from its power source. Turn the handle on each locking pin clockwise to remove it, or counterclockwise to remove it. Then, slide the bay to the front and out of the case. Insert the hard drive in the bay. Use the screws on each side to anchor the drive into the place. Slide the bay back into the case and then reinstall the locking pins. Plug in the cage fan power cord, and you're installed. Now, if you're installing a small drive in a wide bay, now if you are mounting a hard drive into a bay that is too large, a universal bay kit can help you securely fit the drive into this bay. Now, these inexpensive kits should create a tailor-made fit, Now, as you can see behind me, you see how the universal bay kit adapter works. The adapter spans the distance between the sides of the drive and the bay. Now, this figure here shows a SATA SSD drive with brackets connected. And the next figure shows a SATA magnetic drive installed in a wide bay. Now, because SSD drives are usually smaller than magnetic drives, you're likely to see a bay kit to fit these drives into smaller cases, or you're likely to need one. Now, to install and configure a parallel ATA drive. Well, following the PATA or EIDE standard, a motherboard can support up to 4 EIDE drives using either an 80 conductor or a 40 conductor cable. A motherboard can have 1 or 2 IDE headers. Each header or connector accommodates 1 IDE channel, and each channel can accommodate 1 or 2 IDE devices. One channel is called the primary channel, while the other is called the secondary channel. Each IDE connector uses one 40-pin cable. The cable has 2 connectors on it, one connector in the middle of the cable and one at the far end. An EIDE device can be a hard drive, DVD drive, CD drive, tape drive, or another type of drive. One device is configured to act as the master controlling the channel, and the other device on the channel is the slave. Now, there are therefore 4 possible configurations for 4 EIDE devices in a system. Now, the primary IDE channel, master device primary IDE channel, slave device, secondary IDE channel, the master device secondary IDE channel, slave device. Now, the master or slave designations are made by setting jumpers or dip switches on the devices, or by using a special cable. Select or special cable, select data cable. Okay. Now, documentation can be tricky. So some hard drive documentation labels the master drive setting as drive 0 and the slave drive setting as drive 1. Now, setting drive 1 setting rather than using the terms master and slave. Now, the connectors on a PATA 80 conductor cable are color coded, and they use the blue end to connect to the motherboard. You use the black end to connect to the drive. Now, if you only have one drive connected to the cable, put it on the black connector at the end of the cable, not the gray connector in the middle. The motherboard might also be color coded so that the primary channel connector is blue and the secondary is black. Now, this color coding is intended to ensure that the ATA 66, 100, 133 drive is installed on the primary IDE channel. Now, as with installing SATA drives, know your starting point. Read the documentation for the drive and the motherboard. Prepare your work area. Be careful when handling the drive to protect it against ESD. Wear the ground bracelet as you work. So now let's look at the steps for installing this PATA drive. Open the case and decide how to configure your drives. Turn off that computer and unplug it. Press that power button to drain the power. Remove the computer case cover. Check that you have an available power cord from the power supply for the drive. You must decide which IDE connector to use. And if another drive will share the same IDE data cable with your new drive. When possible, leave the hard drive as a single drive on one channel so that it does not compete with another drive for access to the channel and possibly slow down your performance. Use the primary IDE channel before you use the secondary channel. Place the fastest device in the primary channel and the slower device on the secondary channel. This pairing helps keep a slow device from pulling down a faster device. As an example of this type of pairing, suppose you have a tape drive, CD drive, and 2 hard drives. Now, because 2 hard drives are faster than a tape drive and CD drive, put the 2 hard drives on one channel and the tape drive and CD drive on the other. Step 2. Set the jumpers on the hard drive. Often, diagrams of the jumper settings are printed on the top of the hard drive housing. Now, if they're not, see the documentation or visit the site of the drive manufacturer. Sometimes you might also be able to look in the back of the drive and notice that it'll be an MA or an SL or a CS for cable select. As the projects that we'll be giving you later on, Project 6.2 gives you the practice researching jumper settings. The table lists 4 choices for jumper settings, and this image here shows a typical jumper arrangement for a drive that uses 3 of these settings. in this figure here and the following, note that a black square represents an empty pin and a black rectangle represents a pair of pins with a jumper in place. And know that your hard drive might not have the first configuration as an option, but it should have a way of indicating if the drive will be the master device or the slave. The factory default setting is usually for the drive to be set as a single drive on the system. Before you can change any settings, write down the original ones. If things go wrong, you can revert back to the original settings and then begin again. If a drive is the only drive on the channel, set it to single. For 2 drives on a controller, set one to master and the other to slave. Some hard drives have a cable. Select a configuration option. If you choose this configuration, you must use a cable select data cable and set both devices on the channel to cable select. When using an 80 pin conductor cable, select cable, the drive nearest the motherboard is the master and the drive farthest from the motherboard is the slave. You can recognize the cable select cable by a small hole somewhere in the data cable or by labels, master or slave on the connectors. The third step is mounting the drive in the bay. And now that you have set the jumpers, your next step is to look at the drive bay that you will use for the drive. The bay can be stationary or removable. You saw both of these bays earlier in the chapter. Follow these steps to install the drive. Decide if it's best to connect the ribbon cable to the drive before or after you install the drive in the bay. Then install the drive and then connect the cable in whichever order works best for your situation. Connect the data cable to the ID connector on the motherboard. Make certain pin 1 and the edge connector on the cable align correctly at both ends of the cable. Normally pin 1 is close to the power connection of the drive. The figure behind me shows 3 PATA drives installed on a system with data cables connected to the drives in the motherboard. You can now install a power connection to each drive. Now PATA drives use the Molex 5-pin power connector. The cord only goes into the connection one way. So before you replace the case cover, plug in the monitor, turn on the computer, and on the other hand, some systems won't power up until the front panel is installed, but if you can, go right ahead and get it fired up. And after you confirm that your drive is recognized, the size of the drive is detected correctly, and supported features are set to be automatically detected, power down the system, replace the cover. Then the next thing to do is to use an operating system to prepare the drive for first use, which is the topic of our next chapter. Now that's all for this lesson. Go online to a course management system, do the hands-on lab 6-2, then come on back here and we'll start off our discussion by talking about setting up a hardware RAID. See you.